project, I decided to combine my interests of graphics, user interaction, and probability. So within the study of probability, I find the Poisson distribution to be fascinating. A Poisson random variable gives the probability a given number of events occur within a fixed interval of time. It is assumed that the events have a constant mean rate and are independent of the time since the last event. So to put this theory into application, I designed a quality assurance test for a fictional company called Initech. The purpose of the test is for potential quality inspector job applicants to determine their reaction time and attention to detail. So the company has a goal to hire someone who can find at least 4 defects per minute with the probability greater than 75%. So there's a test here. When the user goes to the page, they will click Begin Test. And when they do so, they're going to be presented with a correctly installed circuit board picture. And then below that is a 3D model that contains 5 incorrectly installed components. So it's their task to select the non-conforming parts as quickly as possible. So let's begin the test. So as you can see, this is the correct installation reference picture, and this is the model for the user to select incorrectly installed components. So as you can see, there's a blue piece here where a yellow one should be. This component was installed 90 degrees incorrectly. Here you can find a blue resistor where a tan one should be. And then the color bands for these two resistors do not match. So when the user finds all of the defective parts or the time runs out, they're going to be given their results. So this user found 5 defects in a period of 36 seconds. Once we have this information, we can determine our lambda value. And our lambda value is the number of defects found over the time interval. And that's converted to minutes. So we have 8.2 defects per minute. So with this rate, we now can use this to plug into our probability mass function to calculate the probability that random values take on given values. So that's this equation here. So if I was interested in finding the probability that 10 defects were found given this rate, I could plug in my value of x equals 10 to get my probability. With this equation, the probability distribution is found for that rate. So as you can see, as the number of defects gets larger, the probability of those occurring decreases. So as I mentioned, the goal of the company was to hire somebody that can find at least 4 defects or more within a minute, and then have a 75% probability that the user would do so. So how would we determine that? So because the company is thinking they would like 4 or more, what we could do is actually take the complement of the probability where the user finds 3 or less defects, and that's going to be 1 minus the summation of these probabilities combined. So again, this is the complement of the probabilities that the user finds 0, 1, 2, or 3 defects. So if we do that, we find that the user has a probability of finding 4 or more defects in a minute is 91%. So that achieves the company's goal of finding a good candidate. So there's a lot of cool real-world applications for determining probabilities with average rate of occurrence. Although this is really just a mock scenario, it's evident that probability analysis could be used by companies to make smart hiring decisions. In the future, I want to expand on this project. I want to include additional tests and then also draw deeper conclusions based on inference gained from prior probabilities. but it was fun to put some of these tools into a real world application. Thank you for your time.